This review covers circular motion, gravity, and orbits. Okay. What are the units of angular velocity? Okay. Angular velocity is the rate of your angle covered per amount of time. Hence, it is measured in radians per second. Meters per second would be the units of linear velocity. Radians by themselves would just be an angle. What are the units of big G? Also known as the gravitation constant in Newton's law of gravity. The units are newtons times meters squared over kilograms squared. Notice if you look at the law of gravity, if big G has those units, all right, the kilograms squared would cancel out as well as meters squared, and you'd be left with newtons, which are the units of force. In 3 months, through which angle does the Earth travel around the sun? Well, in 3 months, you would cover a quarter of the rotation around the sun. All right, so in 3 months, you'd sweep out a 90-degree angle, which if you multiply by pi over 180, turns that into radians, pi over 2 or 1.57 radians. What quantities does centripetal acceleration depend on? It only depends upon velocity and the radius of the circle, right? The object mass is nowhere to be found in the centripetal acceleration formula. Centripetal force, though, would include mass, and then it would be all three, okay? But for centripetal acceleration, it is only these two. Two horses are on a merry-go-round. Which one has the greater linear velocity? Right? It would be the outside horse, right? It would rotate around the same angle, but because it has further to travel, its distance over time is greater. Similar question, but for angular velocity. Which one's greater? In this case, they would have the same angular velocity because both horses, regardless of radius, would travel the same angle in the same amount of time. All right. Tripling the velocity of a rotating object requires how much force? All right. This is one of those ratio questions, right? So if everything is kept the same, except for the velocity, notice it's squared in the formula. So if we just assume everything's 1 and then just triple the v, then we would get a force that is 9 times greater. Okay. Similar question, but the change now is doubling the radius of the rotating object's path. This would require less force. And notice because the radius is in the denominator, that is why it goes down. The fact that it does not have a square, we don't get 4, right? We only get 2 times less or half of what we had before. Where does a satellite move the fastest when moving in an elliptical path? It moves the fastest when at perigee. Perigee is the closest location to the Earth. Apogee is the furthest. That's where it would move the slowest. Right. In our virtual circular motion lab, what was responsible for the centripetal force? Right. It was the weight of the washers on the bottom of the string. All right. It had nothing to do with the object's mass, right? The washer pull was what pulled the mass inward. The mass of a person is 80 kilograms, right? And the radius of the Earth is approximately 6,400 kilometers. How much would this person weigh at a location that was 12,800 kilometers from the Earth's center? Really, this is a ratio question, right? At either location, the object's mass would still be 80 kilograms, but the weight would change. And we know at the surface of the Earth, the weight would be roughly 800 newtons. But as we move further away, in this case, exactly double the distance, right? Because of the inverse square law, the force of gravity would decrease by 4 times, right? So this person would only weigh 200 newtons at this particular location. Right. Now we know the Earth has an acceleration due to gravity of about 10 meters per second squared. We have this fictional planet iStem. Its mass is 5 times greater than the Earth, and its radius is 3 times larger. How strong would the acceleration due to gravity be on this hypothetical planet? Well, there's 2 changes here. Remember in Newton's law of gravity, right? If we have an increase in mass of 5 times, that would increase gravity by 5. But the fact that the radius is 3 times greater, right? Our distance is triple, and that's squared. That would lead to a decrease in gravity of 9 times. So with both those changes, we would get 5/9 of Earth's gravity, which is 10. 5/9 of 10 is 5.5 repeating meters per second squared. Okay. A rotating object completes 2.5 revolutions in 1 second. The radius of its circular path is half a meter. What is the object's linear velocity? We basically have to find the ratio of distance covered to time. And in this case, we rotate around the circle 2.5 times, so that would be 2.5 times our circumference in exactly 1 second. All right, if our radius is a half a meter, 2 pi times r is our circumference. Notice we would just get pi times 2.5, and that is roughly 7.85 meters per second. Okay. Good luck on your test this upcoming week. Be sure to study your Edpuzzle video reviews and your study guide.